The broadcast is now starting. All attendees are in listen-only mode.
Hi, good afternoon, everyone. My name is Lorenzo Bossi. I'm the Sales and Marketing Manager here at CompoSIDE. And joining me today is Jonathan Evans, our Application Engineer.
Hello, everyone.
So thank you for joining us today. The webinar today will focus on the design of vessel structures, particularly keel structure, and we'll do a live demonstration of the engine girder. So just as a reminder, this is the second in a series of 4 webinars. Last week we made an introduction to CompoSIDE and yacht with the scantling capabilities. The webinar has been recorded, is available on the support and training section of our website, alongside with examples of scantling reports, bill of materials, and sections and laminate exports. The webinar shoot today, so as I mentioned, a live demonstration of the engine girder design will be followed next week by more of a detailed component design with rudders and keels, and we'll conclude at the end of the month with more of, let's say, an advanced design with very complex laminates formation and 3D design with bulkheads and penetration reinforcements. So the agenda for today is to provide you with a brief introduction to CompoSIDE. We'll then just go over what are the main modules part of the suite and jump straight into the live demonstration with a few iterations between beams and section design, engine girder design, and then review of the same beams and section before completing with automated reports generation. At the end of the session, we'll keep some time for question and answers. You can type those questions if you have any at any point during the presentation. There is a question panel should be on the right-hand side of your screen. Please do feel free to type those at any point, and we'll answer those at the end of the webinar. Okay, so for an introduction to the CompoSIDE environment, this is basically an integrated platform. It allows you to define projects, and particularly for yacht and marine applications vessels. It also serves as a centralized database and management tool for your materials, plies, laminates, alongside with classical laminate and, well, extended classical laminate theory. It allows you to integrate scantling capabilities according to ISO and GL guidelines, but also to engineer your own parts and products with help of 2D and 3-dimensional design modeling and finite element analysis tools. All those modules are integrated in order to provide an automated and versioning engine for reports and bill of material generation. CompoSIDE is composed by a number of different modules, each of which is dedicated to a particular phase of your design activities and engineering activities. The first module in order is Project Space, which allows you to really create projects where you'll be working on with a number of your colleagues in order to create parts and products. Project Customization allows you to define specific safety factors, failure settings of bill of material settings, such as the usage and wastage factors that you can have according to a selected material manufacturing process. CMDB and Plygen are the modules dedicated to the material management library. It allows you to start with a basic material library of roughly 60 generic materials that we will provide as soon as you register for trial or the commercial edition, but also to create your own new materials using micromechanics integrated into the Plygen module. CMDB acts as a central storage place for materials. It allows you to store all your properties for calculation, perform material comparison via, for example, normalization charts, or material selection through scatter plots and further refinements, such as search a material by specific properties. The materials are organized as a central company library, and then you can shortlist the materials you want to use in your own project in order to just work with a subset of those, whether you may have thousands of materials used across a large company, but you will only see only a subset of those in the active project. Now, CMDB is very much a management tool for the materials. We also supply material data. This is called the CMDB add-on, which contains 1,250 plus materials data, including cores, fibers, resins, adhesives, woods, plywoods, plastics, and metals as well, and close to 900 plies. All the materials are manufacturer independent, aside from the cores, and are provided with characteristic values from multiple sources. It's important to note that all the materials are fit for design and FEA, so you have immediately at hand all the properties you need in order to perform your basic engineering calculations down to a detailed three-dimensional finite element analysis. You can directly export material, plies, and laminates to external tools such as ANSYS, ACP, Nastran, OptiStruct, Radius, but also export the data to Excel if you want to create your own reports or further processing, or directly connect through the API if you want to create an integration with some Python scripting, for example, with other tools you may have. I mentioned earlier there are a number of material libraries. So the company material is a private environment which only you as a customer or a trial customer have access to, and we supply an initial 60 materials. You can add your own materials by inputting the data or importing from Excel, for example. If you need a larger subset of materials, we offer those 1,250 plus in the form of DCS material library. And the process is really just to take the materials you're interested in using in your projects and drag and drop them into the active project material. So as you can see, maybe we have, well, in CompoSIDE we have close to 1,500 materials in our library, but we can work with a subset of 20 across all the modules just for the active project. And you can do further material selections by grouping them according to categories that make most sense to you. Mina Space is a tool dedicated to the extended classical laminate theory. It allows you to define base laminates and an unlimited number of sub-laminates. Once you have defined the laminate, you can review the engineering constants, allowables, through thickness shear, sandwich stability, perform load calculations, and recently added also the coefficients of thermal expansion. In Mina Space, you can store all your laminate alongside with all your engineering report. You can create automatically detailed reports that you can then save and share in form of PDF files, directly create shells, and also very importantly, no matter how complex your laminate is, you can have a very well defined and formatted laminate table that you can export in order to include that into your manufacturing drawings. Section Space is the model we spend a good part of the live demonstration today. It allows you to basically create, import, or model your own two-dimensional sections or beams. Those can be defined as thin-walled or solid section, and you can apply either materials or layered laminates directly from within Section Space to any of the sections you design. You can also review anything in terms of section properties, load capacities, allowable loads, reserve factors. In essence, it's a tool that, if you are used to work with conceptual design or BIM models, allows you a very quick and fast design and optimization process. FE Space is the three-dimensional finite element modeling environment. Similar to Section Space, you can import, create, or model your own geometry starting from a number of templates that we provide. The tool offers automatic meshing capabilities with features for manual refinements when you want to control the quality of the mesh. And the solver works for linear, backlinking, and model analysis. All the calculations are sent into CompoSIDE servers that allows the computational time to be reduced to just a few seconds, and then all securely stored. So whenever you open a model, you have a list of all the analysis that you've decided to keep into the same folder. Section Space also offers topology management capabilities, so you're able to define your shapes and your products via means of constraints and so on. Something very important we'll be demonstrating today is that FE spaces can be directly linked to section space. So if you have a two-dimensional section that you're applying to any given structure, you can not only assess the global structures, but you can also go back to your two-dimensional section in order to review reserve factors and so on. Any changes made at that point will be propagated to FE space for a global final assessment. Report Space is the versioning and reporting engine integrated in CompoSIDE. It allows you to create any report really starting from standard templates that are supplied with CompoSIDE or by defining your own custom templates. Reports are automated for anything ranging from laminates, sections, including reserve factor results if selected, down to bill of material and scantling reports. Any report can be issued with a top-level revision issue as well, so if you share a link, everyone has always the most up-to-date version, or can be saved and shared again in terms of PDF files. BOMGen is the module dedicated to the automatic bill of material generation. It collects all the information from your materials, including the prices, your plies and your laminates, and where they've been applied to sections or FE models. It basically collects all the information in order to give you the overall material cost, including usage and wastage factors, according to the manufacturing process you have decided. The system automatically updates so that if you make changes to your materials, if you make changes to your FE models, you can just update the entire report at the click of a button. As you can see, you can have type of just overview with a condensed list of material down to a more detailed report for every subcomponent you may have into your designs. And finally, YachtScan is the scantling tool. It allows you to define sailing and motorboats according to ISO and GL guidelines. But we also recently introduced a pressure override for the ISO guidelines, very useful if you are working with multi-hulls while the ISO guidelines get finalized themselves. YachtScan also allows you to define, to control your vessel management in terms of topology definition. So you can define all the internal deck, all the hull structures, and keep that well organized in folders by either defining them manually, loading simple Excel file with just the names of the folders and the components, down to a more connected link with your CAD system, where it actually allows you to also bring in all the panel and beams measurements. It also allows you to include freely three-dimensional elements into your vessel, so that you're not only looking at a scantling tool, but you're also looking at a full modeling tool for elements that are not generally part of the scantling certification itself. And similar to the previous models, YachtScan offers automated and integrated reports shared via HTML or PDF files, but also give you at-glance information directly for all the beams and panels to see where they are passing or not your guideline requirements. Okay, so that was it for the brief introduction to the CompoSIDE modules. It's time now to enter into the live demonstration, and I'd like to let John assist you.
Great, thanks Lorenzo. Okay, so before we jump into a live demonstration, I just want to go through what CompoSIDE can help you with in your project, in your vessel design. So we have our vessel. CompoSIDE can be used with YachtScan to create a preliminary design. So this is beams and panels, your ISO or GL scantling. It can also be used for detailed design. So we can design detailed areas such as the hull to deck joint within Mina Space, we can analyze local loads such as pad eyes or other components, also within Mina Space. Then we can model this advanced structures such as keel grillages, engine grillages, and bulkheads. So this is what we're going to focus on today. So this is a beam element model. And then it automatically creates a bill of materials, grabbing all of the data from your analysis and your material data. And you can generate pretty quickly a set of documentation, and then that allows you to certify your vessel with the minimum of reporting. So in our engine girder, we have the first step, which is to set up the project and vessel. So as Lorenzo said, how you structure your vessel is very important to a company or an engineer. So you can define your topology in the way that makes sense for you to set it up. So you can do it very detailed, or you can have a few folders and tidy it all up in those. The next step is to select your materials. So this is the first module or the second module in CompoSIDE. This is CMDB, where you can create materials, select materials, compare materials, and then order them in a project, so you have a short list of materials that you design with. So the next step is to define your laminate. So this is using just a basic stack up of your materials. You can create very complex laminates which CompoSIDE can handle, and then you can export laminate tables directly from that. Then the next step is section design. So we create our sections for each of our elements in our frame. So you can see on the top left we have a bulkhead with a keel grillage and some longitudinals there. Each of those are a different section in section space. They can be analysed individually just as a 2D element. You can add loads to that section and analyse it, and then bring it into a 3D space. So you can analyse it with loads, boundary conditions, and under different analysis types. The next step from there is to assign materials and laminates to your sections, and then create it in a 3D space, as I said. So to make a girder design where you assign your load case, your loads and boundary conditions, and then you analyze those results. So then the optimization loop is something that engineers are quite keen on. You want a very, very optimized and quick loop. So this is where CompoSIDE comes in really handy. So any optimization that you need, you can change your materials, laminates, or your section, and then that will automatically update downstream where you can analyze your section or your 3D grillage automatically just by bringing in the new data and clicking calculate. It's very quick to send away a result to our server, usually about 10 to 15 seconds, and then you get your results. On your final optimization loop, once you're happy with your results, you're happy with your weight, cost, and reserve factors, you then create your documentation. So this is your bill of materials and your reporting. So your bill of materials and section reports, laminate reports, or your yacht scan reports. So let's jump into our environment. So you can see here that the modules are laid out in the order of your project. So we're going to start in project space, where we set up our vessel or our project. You can see that I have all of my materials in here, my material selections, my laminates, I have all my beam sections, and my reports are all nicely detailed in here. So I also have a few products. So you can organize this in the way that makes sense. So in one product I have a keel design because I wanted to keep that fairly separate. But in this example we're going to have our engine grillage within our vessel. So it's all in one group, which you may remember we used in YachtsCamp last week. So we will have our YachtsCamp panels in here as well. And what I've done is I've just created an internal folder in which I have my engine grillage. So in project space we can also define our bill of material settings, so our wastage and usage factors, and our analysis settings, so our different failure criteria with the failure theories and our reserve factors or our safety factors that we apply to our projects. So we have our project set up. The next stage is to create a list of materials, which we jump into CMDB for. So as soon as you jump into CMDB, you have your list of your project materials. Typically, if you have a new project, you'll have a few materials which are automatically assigned to the project. We can easily grab other materials from the CS material library, which is the CMDB add-on, or your company materials, which someone or you have filtered out and selected the correct materials which your company want you to use, or you want your other engineers to share. So we can just drag and drop those into our active project materials, and then we can create selections from there. You can also create new plies within CMDB, so you can create it by a new project material and inputting all the mechanical properties. We also have a micromechanical generator, so you can use PlyGen to create a ply using your processing type, your matrix material, and your fiber material, and this will automatically create the properties for you. If you have all your data already in Excel, you can simply convert it to our import format and then just bring it all in. It will populate the list and all the properties for you, ready for you to use. So I have my materials in my project. The next thing to do would be to compare the materials. I want to know which materials I'm going to use where, which materials it makes sense to use with cost, weight, strength, for example. So I have a material selection here called pre-preg plies, and I can use a scatter plot to very quickly have a look at a nice visual representation of how they compare against each other. So I'm going to compare density versus allowable tensile strain in the 11 direction. So you can see that it's very easy to have a look and compare against other materials depending on your parameters. You can also see that we can compare a few other types of materials, so you can compare your fibers with your metals, your fibers with your woods, and really kind of have a look at the difference between your materials. If you're doing a hand calc, you can work out very quickly the difference between those materials and use a scaling factor to play around with your laminates. So some of our customers use CMDB just as a material database. Another function that we can use in CMDB is exporting to other FEA platforms, so Nastran, OptiStruct, or ANSYS ACP. We can also export to Excel, and you can plug these into your existing spreadsheets. If you've got quite a global team and you've got quite a spread out team, this is quite a good way of keeping all your materials in one place. It's accessible, it's online, everybody can get to it wherever you are in the world. So it's all up to date. As soon as you change something, someone else can grab the same data as you. Okay, so I have my material selections. The next thing to do is to create a stacker. So for this we need to jump into Mina Space, where we will create a stacker. So you can see I have quite a few laminates in here. Let's hide these, and I'll create another laminate. So just in Mina Space, I'll create a laminate family, and let's call this Transverse Shear Web. And when we select our fiber type and manufacturing type, these are used in bill of materials generated later. So this takes into account the usage and wastage factors that we've mentioned earlier. So this is going to be a carbon pre-preg stacker. Okay, so once we are in Mina Space, we need to create a stack up. So we can select a few plies for the inner skin. This is a shear web, so I'm going to create a couple of plies of biaxial at 45 degrees. So you can create as many plies as you want. It's not final, you can edit them later just by double clicking and changing the parameters. So I'm going to add these to my stack, and then I'm going to create a core. So I can choose a core. Let's go for the T10, and I'm going to use a thickness of 20 millimeters thick. Now we can also add a multiplier for this if we want to change the type of core or the orientation of it to compare. So T10 is an orthotropic core, so we can also change the orientation of the core to get the different properties in each direction. So I'm going to use this at 90 degrees and hit add. So as my shear web is going to be symmetrical, I'm going to use the sequence type to mirror it automatically around this core. So anything that I change on the top skin will automatically be mirrored on the bottom skin, which is a very good way if you've got quite a big bulkhead laminate, for example, and you've got a lot of tapes, a lot of plies, and it needs to be symmetrical. You don't want to spend all of your time making sure that they match up and then mirroring them manually. Okay, so another good functionality within Mina Space is using sublaminates. So this is our base sublaminate. I'm going to create a sublaminate which is going to be single skin. So single skin. And then all we have to do is select the plies or the cores that we want and tick them. And this is a very good way of creating a few different sublaminates with a basic set of materials in the order that they're going to be. So you can either do this with single skin areas or you can add reinforcements. It's really up to you how you use it. Okay, we have our sublaminate defined, or our sublaminates defined. We can save and close, and what CompoSIDE will do, it will grab all of the data, it will calculate the properties of the laminate. So you can see here that initially we've got our generic data, our thickness, weights, density, unit price if we've assigned one in CMDB. And then we can go on to more detailed properties. So we can go into our engineering constants, our in-plane, out-plane stiffnesses if you want to do a quick few hand calculations. We can also check the allowables, so our allowable bending moments for different failure modes. For example, in my X direction, I want to look at fibre failure. I know initially that, or instantly, that my maximum bending moment is going to be this. It also gives you a bit more detail on which plies are going to fail successively and in which order. And you get allowable strength for your in-plane, for each skin, total laminate, and your shear strains. We can also analyze the sandwich stability, so for different conditions, you know the critical load that your laminate will take, your critical stress and critical strain. So these are very good for hand calculations. And then we can also add loads directly to our laminate. So this is very good if we want to add in a load for our halter deck joint, for example. We know the bending moment at the top of our topside panel. We can plug that in and work out where it's failing, how it's failing. So very, very quickly get an idea of the laminate and the reinforcement that we need at that joint. So we have our laminate. In the Keel grillage, on the engine grillage design, the next thing we need to do is create a section. So we'll jump into section space for this. So I have quite a few sections in here already. We're going to go through creating a new one. So if I right click, create beam section, and let's call this transverse beam, and we'll make it a thin walled section. And this is our 2D editor. So once it loads up, we can create any geometry that we want in here. So we can create it manually by using our editors. You can use circles, splines, arcs, polylines, or just lines to create your geometry. We can also import this from a DXF if you've defined it in a DXF. Or we can generate it from a template. So I'm going to use the template generator tool today, and we're going to create an L-flange beam. You can see that you can create I-beams, hollow rectangulars, or C-beams. And this will generate it parametrically once we've put on our width, height, and capping width. So our overall width is going to be 200. Height, let's go for 300, and our capping width is 100 millimeters. Okay, so once we hit create, you can see that this is all created with constraints. It's got all the constraints that you need. If you want to play around with the beam height, beam width, very easy to do just by double clicking and we can play around very easily. So once we have our geometry, we want to apply materials to this. So we can create a layered section element for as many lines as we want. So if we go for shear web, we'll use the example that we used in Mina Space. We use our shear web geometry, and then we can apply our stack. So this stack we can add materials in, and this is directly linked with CMDB. You can see I have my pre-preg ply selection, and then I can go down to all of my materials that I haven't already used in my selection. Or I can create a laminate family. I'll bring in my laminate family and link it up. So that's what we're going to do. We're going to select my laminate family, transverse web, and then my sublaminate. So I've got my transverse web and I've got my single skin laminate. So let's choose the base laminate. Okay, so I've brought my laminate in. This is linked with Mina Space. I can edit it directly from section space. I can add or I can tick or untick plies directly within here to define my layout. So okay, let's save and close. And then we generally do this for all of the elements to create the rest of our section. So let's go into a bit more of a detailed beam. So let's go for longitudinal outers. I don't want to save this. Okay, so we can have a look at the section properties in here, which we can export directly to Excel. So once this is generated, this will give us a direct export where we can link it in with our existing spreadsheets. We can also add loads in here, so we can add any moments, any shear forces that you wish. You can add a torque in here, or we can just generate our allowable load. And this will give you, for example, you want to know the maximum bending moment around the y-axis. You can click allowable load for MY, and it will give you the ultimate bending moment for this. Okay, so this is taking a few seconds because of my internet. Let's refresh the page. Okay. Okay, so I have my section. You can see that you can get quite a simple section in here to model your realistic geometry. And allowable loads, I can already bring these in from FE Space once I've generated my model. So you can see that I have loads here which are imported from FE Space, and I can calculate them. And this will give me reserve factors for each of my components. You can see that this is quite a high reserve factor. Okay, so we have all of our sections set up. The next step is to assign it to a 3D geometry. So let's jump into FE Space for this. Okay, so you can see here that I have my products again, my topology as we saw before. It's all of the modules, so it allows you to keep all of your components tidy. Me personally, I would have an engine grillage folder where I would have my sections and my frame models, and then this would then propagate all the way through to bill of materials generator, report space, and keep it all in one nice folder. Okay, so the majority of my engine grillage is finished. If I just show you each of the section properties, you can see that it's all individually defined, but I only have to create it once for these 4 beams, for example. So I need one more beam, which is on the outside of my longitudinals on the outside of my grillage. So all I have to do is right-click on the beam and create beams. Okay. Where we grab our edges, exactly the same as we did within section space, then we need to apply our properties. So these are linked with section space. We can either select properties that we've already brought into FE space, or we can create new properties. So we can create them manually if you have your spreadsheets calculating your properties. You can either fill in all of these manually, or you can just use section space to link them in directly. So longitude outside, you can see that this is all a direct link, and I can jump into section space through a small edit button on the right, and then change the properties, change the laminates, change the materials within FE space. So I'll save and close this. Okay. So once I have my my section set up in a 3D space, I can then add loads, boundary conditions, so point, edge, point loads, line loads, surface loads, accelerations, and then group those in different load cases. So for example, if I want a vertical load case and a transverse load case with the same boundary conditions, I can use the same boundary conditions within those load cases, just bringing in a different load. As you can see here, I have a vertical and a transverse load case with two different sets of loads, but the same boundary conditions. And as Lorenzo said earlier, we can analyze it under linear static, modal, or buckling analysis. So it's quite advanced. It gives you a very good idea of the structure. So when I calculate my let's select the properties. So when I calculate my model, it will get sent away to the server and take around 8 seconds to calculate, where it will come back and load itself into my window. So you can see here that I have my displacement results automatically come up. So I can scale these up, have a look at how it's reacting. I can have a look at the reaction forces, so if I want to analyze structure further on from this, I can have a look at the reaction forces and moments within the joints at the end of the beams. I can also have a look at the beam element results, so I can have a look at the local displacement using mouse inspection to have a little bit of a closer look into the beams and how they're deflecting. I can also have a look at the internal forces and moments. So this is a very good tool of having a look at the kind of loads that I have on my transverse and longitudinal beams, which we can click on, and we can have a look at the forces and moments and export those to our section space model, or exporting them as a global load to review within our section or laminar space. Okay, so I can review the nodal results and the element results. Another good tool in FE space for a beam analysis is the reserve factors. So I can calculate my reserve factors based on the strength, and you can see that I have 2.329, and this is transverse resin micro cracking, but I can also set it for fiber resin or just minimum as we have now. Now you can see that I have my minimum reserve factor, my material that it's failing in, my failure criteria, and my internal loads. So these are exactly the same loads as I showed you when I clicked on one of the beams. And we can review this directly in section space. So if we use review in section space, we have our beam here with our reserve factor, and you can see that I have my beam loads here, which has just brought it in. So this allows me to very quickly do an optimization loop on this beam. I know that this is quite over-engineered. I've got a reserve factor of 2, so I want this to be a bit smaller. So let's change the geometry of element 2, which is where it's failing, or the geometry or the stack. So if I remove a few plies, I save and close, and it'll update. So you can see that it automatically updated, and then I can use that exactly the same load to calculate my new reserve factors. Okay, so I'm at 1.5. I'm almost there. It could do with a bit more optimization. So once you're happy with your beam within section space, you then go back to FE model. If you maybe changed the stiffness of your beam too much, the load path might have changed. So it's always good to go back and check the global results of your frame. So let's close and go back to our FE model. We'll save this so it propagates all of the changes that we made into FE space, where we can then calculate again, and it will give us our results within 10 seconds, where we can review them again and then go on to the next beam if it needs a bit more optimization. If we're, okay, so we've got our nodal results, element beam results, and we can check our reserve factors again. Okay, so we're still at 1.829, still a bit over, but let's say for now that we're happy with our results. So this is the analysis complete. The next step will be to create some kind of reporting documentation. We want to create an engineering drawing and a bill of materials for ordering purposes. So for this, we need to jump into our reporting tools, so bill of materials generator and report space. Okay, so in BOMGen we have my vessels. So I have a 60-foot sailing yacht, 60-foot motorsports fishing yacht, which is the Keel, the engine grillage, and I have a separate one for Keel design. So these are all separate, and I have each bill of materials for each of those products. So when I update, it will bring all of my materials back into BOMGen. And you can see that I have my internal engine grillage beams. They're not named very well by me, but this is up to you how you name it. This is exactly the same as it is an FE space, so it will just bring all of the data in. And there are a few ways of having a look at your vessel. So this is a global view of all of the materials within your vessel. So this takes into account all of my materials, laminates, and beams that I have defined in YachtsCant. And it also has my internal folder, so my engine grillage. So if I click on internal, you can see that it brings up a detailed breakdown of my different materials, including those wastage and usage factors which we've mentioned earlier. So first thing we want is an engineering drawing. So I want a laminate table for my beams. If I right click on my group, I can export a laminate table or a material table. And this will give me a nice laminate table for my drawing. Okay, so in my engine grillage, you can see that I have a breakdown and a stack up for all of my plies, including a length, weight, and part design weight and thickness of each element. So this isn't a very detailed bill of materials. Let's open a slightly more detailed laminate. So if I export my laminate table, you can see that this is the type of tables that we'd export and copy and paste into our engineering drawing, giving details on comments, any tapes, plies that we have for each of our elements, down to an individual material list and quantity and overall weight. So we have our engineering drawing sorted. Next thing to do would be to create a bill of materials report. For this we'll jump into report space. You can also do it directly from BOMGen, but we'll do it from report space for now. So in BOMGen reports we can create a report, and let's call this bill of materials 2. We can select our product, so this is going to be our 60-foot motorsports fishing boat, and we're going to use our template. These are CompoSIDE templates, but you can modify, add your own as you wish. All components with cost. Once I click Save, all the data will be grabbed from everywhere in CompoSIDE and compiled into one tidy, neat report where we can share with our clients or our bosses or whoever needs to see the data. So there are a few other a few other reports that you can generate within here. So for our laminate space reports, we can generate a detailed report for all of the data within our laminates. We can generate section space reports. So for every section that we have within section space, we can bring in or take out the section properties, the loads that we've applied, and the reserve factors on those loads. And as we showed you last week, we have yacht scan reports, which gives you ISO or GL reports, which you can use to issue and revision your documents. So every issue you make will be documented, and you can view each of those revisions online via a link, or you can provide just a latest report link to your client here. But we can generate a PDF as well. So let's recap what we've done in CompoSIDE. So we've used Project Space to set up our vessel, we've set up our bill of materials factors, we've set up our safety factor settings, and we've set up our vessel or product topology. We've used CMDB to create materials, select those materials, and filter them against a whole company library. We've used those materials to create a stack up in Mina Space where we can compare them with, or we can have a look at the mechanical properties of those laminates. And then we applied those materials and laminates to sections in a 2D form of our beams, applied it to a 3D grillage in FE space, and then created deliverables using all of this analysis in BombGen and report space. So if you're in a module and you have a few questions, maybe you're stuck on how to do something, there is quite a few tools which you could do that. So at the top right you have a tutorials button, which will be, if you're on the home screen, a very generic CompoSIDE introduction, how to add users, creating projects, managing materials. These are basic tutorials. When we go into CMDB, for example, the tutorials will be module specific. So these are CMDB tutorials, managing materials, creating plies using PlyGen, just creating a layered material, having look properties for calculation and normalizing materials. There are a few other ways if you're stuck. You can see CompoSIDE chat at the bottom of the screen. You can message here and we'll get back to you as soon as we can, which is generally quite quickly. If you're stuck on maybe how to, on a small functionality, I want to do this, and we can point you in the right direction. There is another way of having a look at parts in CompoSIDE, which is tech docs. So this is a very detailed way of having a look at each of the individual modules, what the functionalities are, how to use it, and self-helping. So let's jump back into our presentation. So again, we have our project and vessel. We imported our topology, created our material selection, created our laminates, which is our base for our projects, where we then created our sections, assigned our materials and laminates, created a 3D model, analyzed the results, and used a quick optimization loop with automatic upstream updating, downstream updating, and created documentation. So we've shown you a few ways of how CompoSIDE can be used. There are a few successful projects, examples where CompoSIDE has been used. So this is a 116-foot yacht. CompoSIDE was used in the whole design of this yacht, so from the scantling, the beams, the panels, to each of the individual designs. So you can see on the top left we have the bulkhead and keel, or the master bulkhead and the keel longitudinals. These were all designed using 2D and 3D analysis within CompoSIDE. This is a 100-foot yacht, so this is a small retrofit. You can see on the top right that this is a small main sheet grillage. We just needed to check that the new frame within it was stiff enough, and there are a few other components on the yacht, such as deck joints that were analysed within CompoSIDE. Again, another 45-foot high-performance racing yacht. This came into a bit more detailed design, so this was a lifting keel gantry, so this lifts the whole keel up, and this was analysed within CompoSIDE. High-speed powerboat, so another engine grillage. This is a yacht that does 45 knots, and it has three 400 horsepower engines, so there's quite a lot of thrust going through these, and this is a very similar engine grillage to what we saw today, and this was again analysed in CompoSIDE. And a 76-foot sailing yacht. They had a few questions about the deck strains around the rig, so we did a quick CompoSIDE model to check that they were okay, and the load flows, the load paths within the structure was very easy to see and quick to create in CompoSIDE.
And among other examples of using CompoSIDE is is something we presented back in January earlier this year. Is basically a system to automate bill of material generation for marine vessels based on application of the 3A composite products. So you can quickly get in, register. You get in and you have basically a vessel selection. You decide carbon or glass fiber. You then select PVC, PEC, or T10, and the program will automatically generate a bill of material for the size you require for either motorboat or sailing yachts. So there is a YouTube link accessible directly if you would like to see how this works. Otherwise, just a fairly recent testimonial we received about just beginning of the month from Uder and Grillage, supporting how CompoSIDE helps them in the design of high-performance yachts, particularly for structural and scantling activities. Let's skip this one. So, as you may have seen from the communications for the webinar, we do offer a 30 days free trial to CompoSIDE. The project that John is actually showing today and is working on can also be made directly accessible to you, so we have options to share our projects with you, so you're able to basically just review the design steps we've done, review how the vessel was set up, review the analysis, but also to make your own designs. And we definitely encourage you to do so, because it's probably the best way to look at how something works, to experience it by yourself. And throughout the 30 days free trial, John mentioned you have access to video tutorials, live chat for any question, quick question you may have, email support, frequently asked questions, a number of pre-recorded webinars as well. If you would need some more dedicated help, there are dedicated training activities that can be provided. While we also do a range of services, engineering services, so it can be checking up on the design recommendations, material recommendations, and so on. Okay, we have a few minutes for question and answers. I think if you'd like to, if you have any questions, please do feel free to type them into the question panel, which is on the right-hand side of your screen. Meanwhile, I just wanted to remind you, so next week, 21st, same time, detailed design, this time on rudders and keel design, and we'll conclude the following week with the bulkhead and penetration reinforcements. What we'd like to ask you is if you could take just takes just a minute whenever you close the GoToWebinar screen. A web page will be coming up with just 3 or 4 questions, just to see how we did today, whether there is something else that you would like to see, or whether you have any further questions that you'd like to ask us. Okay. Okay, there is couple of questions. So one is the I'm trying to read that. Do we get access to the analysis data from the trial? And I mentioned earlier, if let me see if we get back to the screen. So when you have basically when you access CompoSIDE on your trial, what happens is you have an option to copy any project that we make available to the public straight into your own environment. So that would basically be a copy of the all the materials, laminates, and parts that have been designed throughout this series of 4 webinars. And that also includes the analysis results. So yeah, you get the option to review those and to effectively have a quick look at the capabilities without having to go into the detailed design modeling. Okay, I think we got to the end of the webinar for today. So again, we hope to see you. That was interesting. Thanks for your attendance. Hopefully, we'll see you next Thursday. Next Thursday, 2 p.m. UK time for the 3rd webinar in the series, rudders and keel design. So thank you for your participation today.
Thank you for your time.